Okay, so we finished those. Now we'd like to do these, and let's keep also updating this same file, and then we're going to be working on now the next one, which is using this get. Now this get, how it works, it says like if you give it a number, it gives you the index or null if the index is not valid. So for example, I have a list of 3 elements in my list. 1, 2, let's say that my list is a list of integers, and I have 1, 2, 3 in this order. Now if I use get 0, it should give me 1. It should give me 1. If I give it get 15, 15 is not within the range, so it should give me null. If I give it get -1, it should return null. So I need to be able to add this question if the index is valid. Then if it is valid, I'm going to answer the question. If not, I'll return null. So let's do that. Yes. And it's not already shared? Okay. You're not seeing it? Okay, so now let's do that by doing the get. Okay, this get, okay, do we have something to copy from? Well, I don't know. Get first, maybe? We had something called get first. No, it's just do something like get, which is going to be more general. So get, and then it needs an int index. That's what I wanted to have, something like this. So it returns something. So let's do something now. How can I ask if the index is valid? So first of all, let me do a if else. You remember, you know these shortcuts. I'm not sure because if you've been using it means so much in the past, but if you type if and tab, it gives you the if only. If you type if e and tab, well, you have to type it in one shot. If e and tab, it gives you the if else. So anyways, these are just shortcuts. Now if the index is less than 0, of course this is not acceptable. Or if the index is greater than what? Length -1. And we have something that calculates the length for us. So we can just call the method length that is going to calculate the length just -1. So if it's greater than length -1, or if it's greater than or equal to length, because if it's equal to length, we don't want to return it, right? Because it's an array from 0 up to length -1. That's going to be the valid indices. So either I do this or this one. Which one is the clearest for you? This one or okay, hold on. This one or I don't know. This one or this one? In both cases, I'm going to return null. So if it's equal to the length, is it a problem? Yes, it is.
Yeah, it should be.
It is a problem. Let me just get my board ready.
It's gonna start from 1 up to like more than the number of the index.
Yes, it is. That's right. That's the problem. Okay. I think I clicked on this. Now something is running. Oh, I forgot to quit sometime. 79 minutes running, mashallah. Okay, so this is my list. I'm just making a list of ints, of integers, and now this is 1, 2, and 3, just to get confused with this. Now this points here, this points here, this is null, this points back, this back, this is null, and this is my head, this is my tail. Now, what is the length?
3.
The length is going to return what?
3.
2 or 3? 2, right? No. How did it come through? What's the code of this length? Let's come back here. This length starts from the head and it keeps going until it's null. When is it going to temp be null? Because every time temp is going to be temp.next. So this is the head temp. When I get inside, I increment the count. So I count this one, 1. Then I move here, 2. Then I move here, 3. Then I don't move anywhere and then I get out. Which means this counts. This should be 3. Does it? Are you sure? No, I'm not talking about the index now. I'm talking about the length. This method here. What is the output of this method? What is the outcome? If I call this method, this is going to return a number, an int. It's not going to return, it's one number. So 3. How do we know? Let's just make sure. Let's follow up. I'm just would like you to be sure 100% of the value of count. Now this is count. This is count. It starts with 0. We initialize temp to be the head. This is temp, and this is pointing at the head. The question, is temp different from null? Yes. I get inside. There's nothing inside. Okay, increment count. Count becomes 1, and temp becomes temp.next, which means temp now is here. Now the question, is temp is null? No. Get inside. There's nothing inside. Increment. Count becomes 2. Then temp becomes pointing here. Now ask the question, is temp different from null? Yes. Get inside. Nothing again. Count. Incremented. Temp. Move to the next. What's next? Null. So now, is temp different from null? No. I get out. What's inside of count?
3.
So I return 3. Not 2. Not 1, 2, 3. Alright, convinced? So now let's go back to our gets. This one. Now if somebody asks me, give me the element at position 3, is there any element at position 3?
No.
Because this is the position 0, position 1, position 2. That's why if the length, the index is equal to the length, I'm going to return null. And if it's greater, of course it's going to be null. So now alhamdulillah we all agree that this is the condition to return null. If this is not the case, how can I return the element at that position? What should I do? If, for example, somebody asks me, we call this get with 2. 2 is less than 0? No. 2 greater than 3? No. So I go to the else. So what should I do? I need to return the element 2. I need to start from the head. Next, until I find the 2. I count that I moved 2 times, and then I get out and return that element. So I need the same loop that I did for this length. It's basically the same calculation here. But anyway, I need just the loop now. I'm going just to copy this loop. This loop is, do I need to copy it though? Can I just not copy it? Just to see if I can remember how to have this for loop. It's 4. And okay, what's the counter? The variable, we called it temp. Okay, fine. We started from the head. But what is the data type of this temp?
CD.
It's a node. So DLL node t. Okay, we did this. Then the question is temp not null? And then the incrementation is
that's next.
temp.next.
No, temp, yeah, equal.
Temp equal temp.next. Yes, so now this is how we move from one to the other. So now I need to give me the index 2, which means I need to count. When count is equal to 0, I'm not going to return it. When count is equal to 1, I'm not going to return it. When am I going to stop? When it is 3. 3? When it is the index. So, this is when my loop will stop. So I need to change this when my loop stops. I need to have some kind of a counter that counts the elements that I'm in. This is the first one, this is the second one, this is the third one. Once I reach the one that I want it to stop. So I can just change this condition and to make something like I'm going to have a counter that starts from 0. And then as long as this counter is less than, or you know what, is not equal to this index that because I'm controlling these. Now I know that the index is valid. Because if I'm here, I know that the index is valid. Now, all I need to do is to count from 0. Once I find the index that I want, I stop. Yes.
Let's say if he puts like index number 2.
Yes.
Then will stop before it.
Why before? Why do you want to stop before it?
That's because of the condition.
Which condition?
The account does not equal to index.
Okay. So what do you suggest? I don't understand what your suggestion is.
No.
You think that this is a problem?
Yeah, I think that's why.
Why?
Because it doesn't equal to index, but these are gonna give us the index that he wants to check.
Okay, now what we're going to do, okay, let's just erase these scribbles, or maybe just not all of them. Let's go back. This is our head and tail. Now index, let's just keep going. Then we have index. Now let's say index is 2, so 0, 1 and 2. The index is 2, and we'd like now to have the count to be 0, right? So the first time count is 0. We just ask, is 0 different than 2? Yes, it is. So get inside. What should we do? Increment the count. Because once we increment the count, then we move, the temp is going to move. So now with 0, it's not equal to this what we want, so we get out.
So it's gonna be 2 now.
Now it's going to be 1. Okay, so it's going to be 1. And then temp is going to be, sorry, temp, we forgot about temp. Temp was here. It's going to be moved to here. And then I'm going to ask the question, is count different than index? Yes, it is. So we get inside, we increment the count, it becomes 2. And then temp now points to here. Now, is count different than index? No. I get out. But when I get out, where is my temp?
Oh, okay. Yeah, the last one.
In the one that I want. Not the last, in the one that I want. Because now the example was with index was 2. If it was 1, it would not be the last, right? With the one that I want. So I just need now to return temp.info. So return temp.info. But there's a problem. What is the problem? Exactly. The temp is initialized inside the for loop, which means it's not known outside. The easy fix is declare it outside. You declare it outside, and you can just initialize it in the for loop, and then you return the info. and this is going to give us either null or the element that we're looking for. Is that okay? Not sure? Want to try it? Let's try it. I'm sorry?
I thought you wanted to edit the new one.
Edit? To add? No, the insert. There's one coming up with the insert. Yeah, there is. There's one coming up with the insert. But let's not. But this is how this is going to work, inshallah. To try it, let's just try it easily. I don't want to go too fancy. Let's go to the integer, and it's much easier. Let's add another option. Let's make the option to be I don't know, we have 1 2 3 7, and then there's no default, right? So since there's no default, we can still add any number that we want. We keep 8 as, because I don't want to make too many changes, but 9 is going to be get element at index. So once I do something like this, do I have to put them like sorted? 1 2 3 etc. No, not really. But it's better too, because it's more, it makes your code organized. But I don't have to, but because I'm lazy now, I just want to get things done. Just to prove it to you, I don't want to spend too much time. So now in index, I'm going to ask index, what is the index, and then I need to read that index. What is the reader do we have? Stender in, so copy this, and then I'm going to display what should I display? Result. Oh yes, that's the get. Don't put too many. So this list, is it called list? Yes, list dot get at the index. Okay, let's try to run this. It's going to run maybe. Oh, let's run this one with the 9. With the 9, yes. So let's put 9. I'm just get the index. There's nothing. It's null. There's nothing in the head.
Yeah,
But it's asking me enter the element to the head because I forgot something. I forgot the break. Let's go back now. Let's add something to the. I'm adding to the head. It doesn't matter now, head or tail. This is the number. And add to the tail 2 and tail 3. So if I display them, this is what I have: 1 2 3. Now let's print get element at position 2. I should see 3. Get element at position 99. It's null. So it seems to be working. Let's test another one. Get element at position 0 or 1. That's 2, which is okay. So alhamdulillah, it works. So just to make sure that it is working, we have this. I just tested it because I saw some not convinced eyes, and I wanted to make sure that you're sure that it works. So now, this being said, let's do the fun of the insert, because the insert at is something. For example, if I'd like to insert an element in the, for example, I'd like to insert an element at 2. Let's say insert at 2. I'm going to like to insert a new element here between the two, between the 1 and the 2. So that's what I'd like to do. So if I call insert at, because insert at takes 2 arguments, you give me the index and the element. Let's say, for example, I call insert at 2, or that means this is going to become my new 2. I create a new object, and this object should be in the middle here, which will involve me having this one to be the next now to be here, and the next to be there, and the previous to be here, and the previous to be there. So it's a lot of fun, and a lot of scribbles as well, spaghetti things, but we'll get to that.
What do you want to change it?
I'm sorry?
What do you want us
To change the value?
Yeah.
No, insert, that maybe change. Well, that's a good idea. Change at, that would be another maybe method to add. But yeah, let's do this one. So insert at now. If I do the insert at, let's go back to here. It's a void, so it's not going to return anything. And then I need to return to insert an element and then at a specific position. All right, now the fun starts with the following. I still have to check if the index is valid, right? Because if somebody tells me insert at an index that doesn't exist, I'm not going to do anything. But if it doesn't, I will do something. So, no, this. This time I'm not returning anything, basically. I just need to ask a question. So let me just do it this way. So if what? I'm going to do something only if the index that is given to me is greater or equal to 0 and the index is less than the length. Strictly less than the length. Because I want it to be equal to length minus 1 at the best. At the maximum, like the maximum value. Now if this is the case, all I need to do is to create a new node. And then I need to link it at the right place. And this is where I need to think about it. But anyway, let's create the first things, the easiest things first. So I need to create a doubly linked list node. And let's create that. So this is the new node. I'm going to name it like this. Equal new data node. And I have the element that is the one I have. So which means that if I do something like this, the previous and the next is going to be null. When I initialize with this constructor, the previous and the next are going to be null. All right? You all agree, right? You're not sure? Let me click here with the control key pressed. I can click on this constructor. It takes you to this. When I give it only the element, the next and previous are going to be null. All right? So let's go back. And I can go back this way. Now that I have created this, I need to make a lot of changes. Okay, first of all, let's just know what are the changes that I need to do. Okay, let's go back to my board here. Now let's say I'm going to insert something here. Oops, no. Brush. I'm going to insert something here. And let's say that I'm going to call the number is 5. And I would like to insert this 5 between the 2 and the 3. So what should happen? Now let me change the color. This should be changed to point now to here. And this should be changed to point down to here. And this is the previous one here. Now the next one should be exactly the same as at what was here. This one is going to be basically there. And what was here, I'm going to choose another color. I don't know if this is still going to be easily readable. This one that was here, pointing here, this is the one that it now needs to point here. I'm just showing you what I need to copy where. Because I need to copy this and make changes as well. So this is where I need not to get confused. So the first thing is I need to start my temp the same way I used to. Let's go back to another color. I need to have my temp start from here until I reach the position before. And then from there, I need to make the different changes to this next and the one afterwards. Or I can just, not the one before, I can just go to that one and make the changes. It's whatever is convenient.
Wouldn't it be more efficient if we go to the one that we're gonna insert then change?
What do you mean?
Is it more efficient to go first to the one that we the one that we insert then change, or?
What doesn't make, we will need to make a change in both of these. The new one has to have some changes because now remember these are null, both of them.
Yeah.
and these have to change as well. So I have to change different places. I mean 4 things, or 6 things. The next on this one, no, 4 things. The next on this one, the previous on this one, and the next and previous on this one. So 4 things need to be changed. Now, how do you want to do that? I can make the temp stop here, and then from here I can get the next and etc. Or I can make the temp stop here, and then do the opposite, the same thing. Because from here I can go back and no problems. What do you want to do? Stop before? Why not stop after? Because it will be easier, because I can use get. Remember the get? What does the get give you? It gives you this one, the position that you would like to put before it something. So it will be more efficient to use the position before, because you don't need to go and then come back. But it will be easier to use something that we already have. So that's why I wanted to suggest this to you. Let's use the get, because by using get I can get the node of the last of, I mean, let's give it a name. I'm going to do something first just to make things easy and not less confusing. I'm going to create a lot of variables. So I'm going to say node after, and I'm going to create another one which is called node before. So this node after, I will initialize it with get with the index. And why is it complaining? It is complaining. I know why it is complaining, but because I forgot something. This is a node after. So let's just do each one of them at a time. So node after equal new, because I'm returning t. I'm not returning the node in this get. So I need to. I'm still going to miss the next and previous. So when I said that I can use the get, that was not. This is not going to help me, because the get is only giving me the value and not the previous and next. So I forgot that. So this is. It was a nice try, anyways, but it will not work, because this get only gives me the t, which is the number, not the previous, not the whole node. If I was returning the whole node, it would have been much better. For example, if this was returning temp instead of temp.info, then I have everything. But the question was asking just about the info. Well, since we're making a new one, let's just make the one that is efficient anyways, because we're going to make a new one that is less efficient. It go to past what we want and then come back and do things with that. So anyways, let's just do it again. So we're going to do the same thing, like something like this, for example, but instead of stopping at index, we're going to stop at index -1. But there's maybe a problem. What happens if the index was 0? Now if I need to stop, I said that index -1, right? I'm not returning anything, and this is going to be, this temp now is going to be, not before return it, at the end of here. Now temp is at the node before index.
Why would you make it insert after a node? Like
At that position, it means you mean after. Insert at. I don't understand. For example, if I put it if I insert after, what would be the index of it? For example, if I call the method insert 2, and then we'll put the 5. Now, what I'm expecting is this 5, this new node, should be at the index number 2. This is index 0. This is index 1. If I put it after the 2, which will be a new node at position 3 now. which is not what we want. We want this new node to be at this position too. So that's why it has to be before the 2. So now if I do something like this. Now I put index -1. Before the -1, I was not having any problem because I made sure that my index is respecting the conditions, that it is from 0 until less than the length, or the length maximum. And now if I put -1, what if the user gives me index? So if the index is 0, index -1 is going to be -1, and then is this going to be true? No, it's going to be false. Is this a problem? Not really. So if I say insert at 0, this is going to be false, and the temp that is going to be returned to me is the head, which means I want to now insert in the head. Just insert at the head. It's like adding to the head. It's like add to the head now. So I'm just going to maybe make a small question that if it's 0, or if it's the last one, in order for me not to get to do a lot of things, I'm going to add to the head or add to the tail. So I don't need to do some extra work. So before doing something like this, I'm going to exclude that 0, or I'm going to exclude the length because I want this to be something different. So I'm going to put another if here. This is going to be my else if. So if what? If the index is equal to 0, it's like adding to the head. So I'm adding to the head that element. And else if the index is equal to this length -1, that means I would like to add it to the tail. So add to the tail. And this is going to help me get rid of those cases, so I don't need to care about them. Now my problem is now I need to put something in the between. Something just tickles me about this one. If this is 3, this is 0, 1, 2, so the length is going to be 3. So if the user gives me insert at index 2, is 2 equal to 2? Yes, I'm going to add to the tail. So this is not okay. What is going to be okay is if I say insert at this number, which is the last one, which is 3. For example, if I say insert at 3, this is actually add to the tail. But if I say at 3 minus 1, this is what I would like to do. I want this to be in the middle. So always double check. When you put some condition, put some values so you can picture what is going to happen. Because I might look like quickly, oh, this is the idea, but then when you try to put some values in them, in those variables, it might now show you that it's not going to work. Now, are you all seeing what I was saying here about this -1? Because if I put -1, it's not going to work. Because now, if I put -1, am I going to add to the tail? I shouldn't, because if this is 3, 3 minus 1 means 2. If I'm asking about adding 2 at this number 5 at this position 2, I want this to be my new 2, so I want it to be in the middle. But if I say 3, this is the index where I want this to be added. Now I have 0, 1, 2, so 3 is the last one, so I'm going to add to the tail. Now this in the between now is going to be either, for example in this case, either 0, we said add to the head, either 1 or 2. If it's 1, I'm going to insert here. If it's 2, I'm going to insert here. And this is what I'm going to do. If it's 0, I'm going to add to the head. If it's 3, I'm going to add to the tail, which is going to work all the time. All right, so now how about this condition? Does it still stand? So if the index is greater than 0, that means if it's 1, 2, etc. Okay, from this first part is okay. Or less than -1?
Yeah, because
If it's less than 2, that means if it's 2, it's not acceptable. Less or equal, just less than the length itself. This length is 3. I want it to be, if it's less than 3, then I'm going to put in the middle. Less than 3 means, for in our case, it's 2 or 1. We want to make sure it's not 0. We want to make sure it's not 3. So that's what we put here. If it's 0 or if it's 3, we do add to head, add to tail. If it's in between the 0 and the 3, then we do our thing that we wanted to do. Is that okay, inshallah? Yes? Almost? Maybe? You got lost? Speechless? Amazed?
we have now like for the index 0, 1, 2, right?
Yes.
If we put the 3, it's gonna go to up to 2 then.
Why?
The index is 0, 1, 2.
Index. We have 0, 1, 2.
Now imagine I'm calling insert. Okay, insert. Now the first one is the index. The second one is the value. So we don't care about the value now.
Yeah, all of them.
Let's focus about the index, right? This is the index. Now this is 0, 1, and 2. Now if I say insert 0, 5, which means, where should I put it? This new element should be at position 0.
Head.
So this is going to the head. This one is okay? Fine. Now if I say, put it at 3.
Yeah.
Insert at 3.
There are no 3, so
That's it.
So it will add to the tail. Great. Now if it's not 0, not 3, which means it should be greater than 0, less than 3, which is remaining 1 or 2. Make sense? So if it's done, I need to find how am I going to deal with it. So that's the point. But before that, something went to my attention, because you see this length here is called twice, and I know that there's a for loop here which is going to be called twice. Why would I do that? I can just declare a variable, or call it size to avoid confusion, and I put this value there, so I don't need to call it twice. I store that in the memory and then I use it twice, rather than having a for loop that runs twice. So now let's call this size, or maybe I can just also call it length. It doesn't matter, because this is length the variable, this is length the method. But I hope you're not getting confused with that.
Sounds better.
Size better? Keep it size. Okay, so now that we're here, that means we're going to be adding a new node. So this is what we did. We added a new node, and we imagine we're going to put it at 1, for example, just to, well, it's a big one, because I just already started drawing it here. So I created this new node. Did I? Not yet. So let me create this new node. Oh, I mean insert that. Okay. DLL node, and let's call it new node. This new node, I'm going to initialize it with this EL, which means now this is null, this is null. This is what I just did, this here. Now what I need to do is that, because I want to insert in 1, I would like to reach before 1. I would like to get here and stop before this, because now this one, the first thing that I would like to do is to change this from here to here. So I need to stop here before the 1, so I can change this next to be this new node. So how can I do that? Or maybe, you know what, let's just make it back to 2, because it will be easier. Let's put back, it will be easier based on this example. Let's put it back to 2 and then 5. So 0, 1, 2, because you were more comfortable with that already. And it's much easier because it might be confusing with the head being that and so on. So now with these 2, I created a new node. I put 5. This is null. This is null. I'm here. Now this temp, what does it do? It just tries to find the one before the last. When this one, I would like to stop here. So my temp here. Now let's see how it works. Temp is in the head. Is count equal to index? Okay, what is count? Count is this variable that I set to 0. So this is count. This is 0. The index, this is the index. Right? The index is, this is what is given as an argument. And now this question is count different to index minus 1? Index minus 1, that means 1. Is 0 different than 1? Yes. So I get inside, count becomes 1, and then temp becomes pointing to this one. Now I'm going to ask, is count different than, what is count? 1. Is 1 different than 1? They're equal, so I get out. Once I get out, the temp is pointing at the one before the index. So it's pointing at the place that I want. Now what I need to do, temp.next is going to be the new node. So this is what I'm doing. I'm changing this to become now pointing to here. So this new node. But I don't want to do that now, because I'd like to make this one, the previous of the next one should be pointing to this new one first, because once I move from here, I cannot go from this one to the next one. So this is going to be not the first thing that I'm going to do. The first thing that I'm going to do, I'd like to do this. So then afterwards, because now to do this from temp, I need to go to the next, and the previous should be my new node. So I'm going to do this temp dot next dot previous is my new node. Then after that, I can just do something like that. But before also, this should be pointing at this new node, that this temp dot next dot previous should be inside the next of this new node. So this new node dot next should have this, and I know you like it now. And I put them in this sequence so I don't lose any information. There's only one thing that is missing, is this one now. This one pointing to the previous, which is very easy. New node dot previous and that's it. I know. So much fun, right? Imagine you have that in the quiz a few weeks from now. You're going to like it. I'm sorry? Yeah, of course. Now that you know. Yes.
So the temp is actually like head dot next.
Well, in this case,
Yeah.
yes.
Yeah, in this case, just
Yes.
So just a variable that has some amount of next, dot next, dot next.
It points to a node that has a next and a previous and so on. It just takes us, as you see, this temp is, when you have access to a variable, it's like now you have access to the whole thing and you can go to the next and the previous of it.
So just the name temp every time gets me. I think it's like
Let's change this temp to the node before. Now I would like to find the node before, or before. What is before? I would like to find the node before, so I find it now. This comment is obsolete now. Now what I need to do, so this is what happens. Let's just cancel all these changes, and I would like to show you. Now I reached here. This is my node before. That's a big B. And this is my new node. So the first thing that I do is the new node dot next, this one. It should be pointing to
the previous one.
to that one. So how can I get that one? It's the node before dot next dot previous. No. What's happening here? Why is previous here? Because dot next dot previous, this is going back to the same place.
Yeah.
So this is not previous, doesn't make sense. So the new node dot next should be the node before dot next. And that's correct. So we were having a problem here. So this is what we did now in this first line here. We set up this to not be null but to point here. Now this node before dot next dot previous means this one. Now this one, we're changing this, instead of pointing here, it will be pointing to this new node. So this is what this does. The node before dot next dot previous, which is this part of here, I'm not going to leave it as it was, but it's going to be now pointing to the new node. Now how about this one? The node before dot next, which means this one here, should it stay as it is? No, it should point now to this new node, and this is what it does. The last thing that is remaining that needs to be changed is this one, which is this new node dot previous. It should be pointing to the one before, which is that one. Do we need to do anything else? No. And this is going to work, inshallah. To prove it, I'm going to change my the same one, the one that the integer, this 9, and it will be insert element at index. So if tell me, okay, what is the index, what is the element, or something like that, and I'm going to let's the element, and then this is going to be the AL, and this is the index, and then I'm going to say insert index element. I prefer element as to EL. Now this insert is not going to be returning anything, so that's why it's complaining that it's inside of a system out the print line. But what I'm going to do after this insert, basically that's not insert, insert at. So insert at is going to be now working. After that, I'm going to call 3 to see what's inside. So what I'm going to do, I'm going to run add to the head 1, and then add to the tail 2, and add to the tail 3. Now I'd like to insert, so let's call this 9. I'm going to insert the element 5 at the index 2, which will make it 1, 2, 5, 3. Now let's display and see 1, 2, 5, 3. Let's try another one. Let's insert at index 0, which is add to the head. So everything should still be working. So I'm going to test it again. Insert like the 6, element 6 at position 0. And display 6, 1, 2, 5, 3. Okay, let's keep going, testing again. Element 7 should be at the last one, which is how many elements do we have?
0,
1, 2, 3, 4, 5. I would like it to be 5. If it's 5, and that means the 7 should be add to the tail. Now we tested it. What if I put a number that doesn't even make sense? If I put, for example, the element is 8 and I put it at 15. What should happen?
Nothing.
It should do nothing. I mean, now it does nothing because there's no 15. How can I put something 15? Why it does nothing? Let's see. It does nothing? Why it does nothing? Why? Because the conditions are all false. It's not going to be true. For example, 15, we are here. Is 15 0? No. Is 15 equal the last number? No. Is 15 between the 0 and the last number? No. So don't do anything. So that's what it does. Nothing. If it's giving you something that is outside of the boundaries that are acceptable. And that is half of what we were talking about. So my advice to you, give this some time. Give it some time. It's not complicated, it just takes time. There's a lot of details, and especially with this pointer thing, you get confused with the next, previous, next, and next, or whatever. Head, tail, and something, temp, so many different variables that you need to play with, and you might easily get confused. I got confused too. I'm not saying that I got confused, and I got confused. I did not mean. Let me just tell you one thing. I did not mean to make the mistake of this dot previous. Sometimes I intentionally make mistakes and see if you can spot them, but this was not the case. I thought it was right. So always when you do something, try to double check it, because you never know. You might look making sense, and then you realize that no, there's a problem, and you have to fix it. So always get it step by step, follow your variables, and double check. So that's pretty much it.